Hello, my name is Viraj Vekaria and I am a third year undergraduate student of aerospace engineering at IIT Kharagpur. Now we will talk about turbulent flow for for JEE and prepare for the topic turbulent flow for JEE examination. For turbulent flow, it's not just on turbulent. The video will not just on turbulent flow. It will also explain laminar flow and Reynolds equation. As it all the topics are coming simultaneously, we need to have understanding of all the things simultaneously. So uh, together, okay. So let's give me first example. Okay, so if you ever seen the agarbatti, the intense stick, there are the flow of the smoke in a very steady way. Sometimes it's steady way in a no, and it is till some length, and then it will go very messy and chaotic, which one can say irregular. And we can see here the flow is very irregular here also. This is due to the flow is going intersecting each other. The flow's line is intersecting each other and making it chaotic. We can see here the line is very smooth and it is not intersecting each other. That's why it is a very steady flow. And based on this, we have the definition of laminar flow and a steady flow, where the uh, flow line, it is not intersecting each other. When it is not intersecting each other, it is a steady flow. And if it is intersecting each other, making it's chaotic, irregular and messy sort of flow, where we can see here it is very wild type of flow above certain height from the agarbatti smoke. So it is a turbulent flow, or we can say unsteady flow. It may a transitional flow also. Let's see one more example of turbulent and laminar flow. When we see a tap water, if the water is very smooth, just like it, we can see it as a sort of glass cube, not glass cylinder. So it will have almost very steady lines, and the line will not interact each other. It will follow its own path. But here it is intersecting each other, and it will create a chaotic messy flow, which we can say is a turbulent flow. This is the difference between laminar and turbulent flow. For mathematically seeing the turbulent and laminar flow, we can't just intuitively say that the flow is laminar, turbulent or transitional flow. uh, uh, we had a no, we had one parameter which says which called as Reynolds number, and which says the difference, which give us the difference of from for all laminar, turbulent and transitional flow. So the Reynolds number are dimensionless quantity, and it is a ratio of inertial force and viscous force. So what is the inertial force? We can think of this as a speed and weight. It wants the fluid to move fast and break rules and create chaos. It means when we give some any flow or any object inertia, it will go in a certain speed, and it make create chaoses. And in the viscous flow force, we can think is as a stickiness. uh, it wants to keep the fluid calm, orderly and smooth. It means if the flow is going in a certain direction, viscous force are restrict them to go like vibrant, go very violent and go into very wild. It it is giving his direction, and it's like sort of stickiness, we can say. Inertial force we can write as rho a v square, and viscous force we can write as eta a del v by del y. It means eta a v by d, which d is the diameter of the pipe. This is a diameter of pipe. This is a diameter of pipe. Uh, then this is also a diameter of pipe. Okay. So based on these ratios, we can write ratio as the ratio is rho a v square by eta a v by d. So we cancel out, a cancel out as rho v d by eta. So the Reynolds number equation is this, where rho is the density, v is the velocity of fluid, d is the diameter of pipe from which the flow is going through, and eta is the viscosity of fluid. It is a parameter which shows the stickiness of the fluid. If the Reynolds number is less than 2000, we will say the flow is laminar flow. If it is greater than 4000, then we can tell the flow is turbulent flow. And if it is between 2000 to 4000, it is going from laminar to turbulent. That means it is a transitional flow. Okay. So this is the basic intuition of the Reynolds number, laminar flow, turbulent flow, the inertia force, viscous force, and all. Based on the ratio, we can derive Reynolds number, and based on the equation, we can have the number of each flow, and based on that number, we can say that if it is a steady, laminar, turbulent, or the laminar flow is a steady flow, and it is an unsteady flows. Both are unsteady flow. We especially mention turbulent flow when it is turbulent, but if it is a transitional flow, we can
Based
say
on
is
this
unsteady flow
understanding,
also.
let's
See one more example of one video.
So this is the laminar flow, this is the turbulence flow,
And
uh,
you can see here, uh, the flow is very chaotic and very messy. It is not going in the perfect direction. It is giving a curly wind, and it is going wild when it is flowing through a pipe. So it is a turbulence flow, and what we have seen earlier, it is a laminar flow. As we can see that here the flow is in a normal direction, in a uh, linear direction, and it is not chaotic, it's very simple. Let's see one more example of the laminar. You can see here the flow is very steady. It means the flow is turbulent, laminar till here. We can see there is a very chaotic flow. It is very imbalanced, and it's going very wild. It's chaotic flow, messy flow. It means the flow is turbulent flow, and before here it is a laminar flow, and between this here the flow is transitional flow, which says the flow is going from is a transition between laminar and turbulent. Understand laminar and turbulent flow with this diagram. As we tell, as I told, that the flow, if the flow is okay, if the flow is steady and it is not intersect each other, as we can see here, the flow is intersecting each other. If it is not intersecting each other, we can say is a laminar flow, and the velocity profile we can say here is like this. And for turbulent flow, the velocity profile, the average almost a flatter type of thing, but when there is no slip condition, due to that always the velocity at boundary will be zero, so it will look like this. uh, we will see it later also, but sort of the intuition is that if there are very messy flow and irregular flow, it will we can say as a turbulent flow, otherwise it is a laminar flow. And for the velocity profile, the velocity profile is not much important for us in JEE exam, but there is no sleep condition for both of this. uh, Turbulent, it is a laminar, this is turbulent. The velocity profile is flatter and it is parabolic. As we seen here, it seems a parabolic, and there is a average flow because the uh, irregular irregularity of the flow and chaotic flow. It seems almost a flatter velocity profile. Okay. So we have completed the theory part of the turbulent flow with the intuition of Reynolds number, the equation of the Reynolds number, from where it comes, the ratio, inertial forces and viscous forces. If the inertial force is very much higher than viscous force, the ratio will be more than 4000. It means it will be turbulent flow. But if the viscous flow is dominating the inertial force, then it will a laminar flow, because viscous flow is a stickiness, is showing a stickiness, and it will go give us a steady flow. Otherwise inertial flow is giving us give the inertia to the flow. It means it will create chaos, and it will give turbulent flow. Let's move to questions. In a flow fluid, if the inertia force are very large as compared to the viscous force, then the type of flow of the fluid is called, it, it is turbulent flow, as we already seen. If the inertia force will increase, then viscous force, it will give us the Reynolds number high Reynolds number. It means it will a turbulent flow. Let's move to PYQs. So the first question and the one ABC part is not relevant for us. The This is false. It is false. It is true. Other two part is important. That's why I put this example here. The onset of turbulence is determined by Reynolds number. So yes, why? As we have discussed, we can't um by just see, we can't say that this is the turbulent flow and this is the laminar flow. For that, showing that, we need to have the Reynolds number, and from Reynolds number, if the Reynolds number is more than 4000, we can say that this is the turbulence. So the onset of turbulence is determined by the Reynolds number. This is true. And in a steady flow, two streamlines never intersect. As I already showed here, the streamlines are will not intersect each other. Also here, the streamline are very steady and it won't intersect each other. That means it is a laminar flow. Then both of these are true. It means C, D or E are correct. And the second question, if rho is the density and eta is the coefficient of viscosity of fluid which flows with a speed v in the pipe of diameter d, the correct formula of Reynolds number. The Reynolds number direct formula is rho v d by eta. We have already seen. So the answer is C. Re is equal to rho v d by eta. Rho is the density, v is the velocity, d is the diameter, eta is the viscosity, and r is the Reynolds number. Let's move to question 3. Okay, so for question 3, we have asked that what will be a nature of flow of water from circular tap. So circular tap, it means area is equal to pi r square. When the flow rate increased from 0.18 to 0.48 liter per minute, the fluid of tap is tap and viscosity of the water are uh, zero point 0.5 centimeter and 10 raised to minus 3 pascal into second respectively. Density of the water is this. So we have rho, we have the viscosity, the diameter is equal to 2 times r is equal to 1 into 1 centimeter, means 10 raised to minus 2 meters square. We need to change all the parameters into one, and we will use SI units for that. Liter per minute, I have already seen that question 3's answer. Velocity is equal to Q by A. And the formula is showing that the ratio of flow rate and area, which is Q by A, and Q for circular tap is pi r square. It means Q by pi r square, and when we put it here, rho v d by eta, if we put rho q by pi r square 2r by eta, it cancel out and gives 2 pi r by pi r eta. So this is the equation for RE, and 1 liter per minute is equal to 10 raised to minus 3 by 60 meter cube per second. We need to convert all in the SI units. When we put all the formulas for Q1 0.18 liter per minute, we will have Reynolds number 3 almost is equal to 382, which means the flow is laminar. And for Q2, it's almost 1019, which also means the flow is laminar. And we have already seen that if the Reynolds number is less than 2000, then it will a laminar flow and it will a steady flow. So we have asked that uh, the nature of the flow. It is unsteady to steady, no, remains a steady flow, it remains turbulent, steady to, it remains a steady flow. The answer is 2. Fourth question, water for a pipe is coming at a rate hundreds liter per minute. Hundreds liter per minute, it is given a Q. If the radius of the pipe is 5 centimeter and the Reynolds number for the flow of the order density of water 1000 kilogram per meter cube, coefficient of water of viscosity we have all these values. And as we did in the question number 3, as we already have all the equations, all the quantities and values, we can put as in the question number 3 we did, we'll put q pi r square or d r all the in SI units into this equation RE, and we will get RE is almost equal to 2.12 into 10 raised to 4, and this number has the multiplier of 10 raised to 4, that means answer is 10 raised to 4. So this is all about the Reynolds number, the turbulent flow, and the laminar flow. We have all seen all the things. Here is the major thing is a turbulence flow. I want to explain you where turbulence flow is a sort of a complex thing, uh, where it needs it for solving that we need very complex math, and it is where it is nowadays a research topic, a research area. We haven't find a proper solutions and a proper things for turbulent flow yet, but we have the basic things like Reynolds number and all. From that we can at least say that it is laminar or turbulent, or it is a transial, it is steady or unsteady. And let's have a small revision. We studied first the difference between steady and unsteady based on the example of agarbatti and the intense stick of smoke and the tap water. Then we move to dimensionless quantities. The ratio is inertial force and viscous force is Reynolds number, and from which the ratio we can classify this into three flows: laminar, turbulent, and transitional flow. We have seen one more example of dam water, from where the flow is coming very steady in a laminar manner, and it transitions to a turbulent flow, and it's not important actually. So velocity profile is not important for us. And uh, we have seen the questions on turbulent flow, the Reynolds number, and majorly questions will be on the Reynolds number. So this is all about turbulent flow and Reynolds number and laminar flow. Thank you.